Is NASA lying to us? Part 2. Do satellites really exist? Let's start with an interesting observation by Eric D. from T.
169. So-called satellite TV dishes are almost always positioned at a 45-degree angle towards the nearest ground-based repeater tower. If TV antenna were actually picking up signals from satellites 100 plus miles away in space, most TV dishes should be pointing more or less straight up to the sky. The fact that satellite dishes are never pointing straight up and almost always positioned at a 45-degree angle proves they are picking up ground-based tower signals and not outer space satellites.
Eric says satellite dishes almost always are directed in a 45-degree angle. Let's travel through the world and check it. I'm not really convinced that it were all 45-degree angles. So let's have a closer look. For instance, Cambodia. This dish is in Phnom Penh. And let's look at some angles. First we want to find out at what angle the dish itself is directed. It seems to be about 25 degrees more or less. But do you notice where the LNB points to? Let's follow the reflection angle for it. It's 52 degrees. Or this one in Laos seems to be directed at about 80 degrees. I don't think we have to measure this one in Indonesia. Indonesia is close to the equator. Do you think that there is a transmission tower right above it, Eric? But since you live in Thailand, I give you another example. It's about 53 degrees this time. Almost the same as in Cambodia. Well, it's your neighbor country, isn't it? But here we can see another interesting phenomenon. The dishes themselves point to different angles, but the signal comes from the same angle. Isn't it magic? Because you have to point your dish at different angles depending on where you live, there are sites like dishpointer.com that help you with it. Otherwise you will not get a clear signal. You just put in your location and the site returns the dish angle and the LNB skew. And because you also need a non-obstructed signal path, there are apps for your smartphone that help you with that too. Just point in the direction of the satellite you want to use and see if there's something in the way. If the view is clear, you will get a signal. There are so many satellites you can tune into in all sorts of azimuth angles. Do you really think in all these directions you will find transmission towers? The coolest image I have found was from a satellite dish in Nigeria. This guy uses 5 LNBs at different angles to receive signals of 5 different satellites. He must get 1,000 stations. It will take him a long time to zap through them. But there was another misunderstanding in Eric's words. Let's listen to them again.
If TV antenna were actually picking up signals from satellites 100 plus miles away in space, most TV dishes should be pointing more or less straight up to the sky. The fact that satellite dishes are never pointing straight up and almost always positioned at a 45-degree angle proves they are picking up ground-based tower signals and not outer space satellites.
Okay, Eric, let's assume for a moment that people would point their satellite dishes straight upwards. This would mean that you need an own satellite for every single dish, because the satellites would have to be exactly above each house. How many satellite dishes are there? A billion? No, pointing your dish straight up won't work. And there is another reason. The orbits of those satellites. In order to stay above you all the time in the same relative position, the satellites would have to stay always at the same latitude. Those orbits cannot work in a gravitational bound system. An object can only orbit around a center of mass, not somewhere above or below it. The center of a circular orbit has to be the center of mass. But if the satellite orbits the center, it will always change its latitude. You would constantly have to adjust your satellite dish. The only orbit where your dish can stay fixed is an orbit above the equator. You will point your dish towards it, and its relative position always stays the same, as it orbits as fast as the Earth spins. The only guys who can point their dishes upward live at the equator, like this one. We can even calculate how far away those geostationary satellites have to be. In my video An Apple, Earth and a Wet Ball, I explain how. For a stable orbit, the centrifugal force needs to be equal to the gravitational force pulling at the satellite. If we take the formulae and plug in the values, we get to a radius of about 36,000 kilometers. I hope that you now understand why we point the satellite dishes at certain angles. So, Eric, all that you can find out with a quick Google search. So before you make your next bold claim, please do care to look these things up first. The next question about satellites is often posted by flat Earth YouTubers. Okay, let's see. First of all, the image they use is very misleading. How about that one? Biologists claim that there are 100 trillion ants on our planet. Why can't we see them from space? But seriously, why don't so many satellites collide all the time? First of all, they are not all in the same orbit. Some are further away from Earth, some are closer to it. But let's for a moment assume they would all orbit at the same distance from Earth, say 500 kilometers, just for fun. The radius of that orbit would then be about 6,800 kilometers. In school we learned how to calculate the surface area of a sphere. If we plug in the numbers, we get a very huge number for the area. But we have to divide it by the number of satellites. Still a big number. Calculating further, we find that each single satellite has a space of 170 times 170 kilometers. How big is the chance of them to collide? And so we can answer the next question from the same video. I guess we need a bigger computer screen for that one. We are looking for an object of 1 to 10 meters in 170 kilometers distance. How many pixels would that be? For comparison, the Soyuz spacecraft you see in 30 meters distance is about 7 meters long. And it gets wilder. The moon in this image is about 3,500 kilometers in diameter, a satellite 1 to 10 meters. Do they really expect to see one in this image? We're not quite finished yet. We have another claim by Eric D. from T.
166. The geostationary communications satellite was first created by Freemason science fiction writer Arthur C. Clarke and supposedly became science fact just a decade later. Before this, radio, television, and navigation systems like LORAN and Decca were already well established and worked fine using only ground-based technologies. Nowadays, huge fiber optic cables connect the internet across oceans, gigantic cell towers triangulate GPS signals, and ionospheric propagation allows radio waves to be bounced all without the aid of the science fiction bestseller known as satellites.
Okay, here are a few points to talk about. First of all, it seems that you just have to say that someone is a Freemason, and suddenly all that he has ever said and done is a lie. You know, Eric, there was a time when simple-minded, Bible-loving Christians persecuted scientists and burned them on the stakes, and the only way to work on finding out the truth about this world was to do scientific research in secret societies. Seems you guys have learned nothing from history. But back to your claims. You said that before the geostationary satellites, all communication was done using ground-based technologies, and they worked fine. Did they really? I was born in the 60s, and I do recall that in my childhood not everyone had a telephone, that there were only 4 TV stations, and there was no internet. Walking also worked fine before they invented transatlantic flights. The first real geosynchronous satellite was Syncom 2, and it was launched in July 1963. It had 2 antennae and could only transmit 2 different signals at once. It was not truly stationary because its orbit was slightly inclined. But let's look further back. The first to have the idea of a geostationary satellite was Konstantin Tsiolkovsky. Although he never actually built a rocket himself, he invented designs for rockets, spacecrafts, and even a space station, just like Da Vinci, who invented the helicopter long before they became real. The next people to mention geostationary orbits were Hermann Oberth and Hermann Potočnik, who both calculated the necessary radius. Arthur C. Clarke made the idea popular and invented a system of 3 satellites that could send a signal to any point on the whole planet. The first time something like that came true in 1964, when television signals from the Summer Olympics in Tokyo were first transmitted by Syncom 3 to the United States, and from there by Relay 1 satellite to Europe. At that time, undersea cables could not transmit the bandwidth needed for TV and all the telephone calls at once. Earlier oversea transmissions of TV signals using reflective balloons always only worked for a few minutes. The first transatlantic cables were made from copper and contained only a pretty limited number of single channels. Before the digitalization, it was difficult to send 2 signals through 1 cable, so their bandwidth was limited. Modern optical fiber cables were started to get used in the 80s. So how could you have millions of phone calls, telegraphs, stock market information and TV crossing the ocean until then? And when you talk about gigantic cell towers, do you mean these? A school friend of mine worked on putting up the CNET in the late 80s. It was still pretty unreliable technology then, and the net only worked in cities. Then, in the 90s, they installed the D and E net, and there are still rural areas here where you can get a GPS signal but not a phone call. And then you mentioned the ionosphere. Do you mean that charged up layer of our atmosphere that bounces off radio signals? The one that is created by solar wind coming from the outside of Earth's atmosphere? That builds up at daytime and gets thinner at night? I would be very interested in your explanation for the very existence of it, Eric. The next hard evidence that satellites don't exist comes from Jeranism.
As if launching these expensive works of technological genius is easy. A single launch of a satellite can cost $500 million. To build a satellite that can just track and monitor hurricanes, $290 million, and that's without the actual launch. Add $100 million or more if you want a satellite that comes with a missile warning device. Now come on, let's just think, let's use our heads. How could they be so expensive? It's a scam. Take a look at this house. This house is in Nebraska. It is $900,000. Do you really think a satellite that is falling around the planet should cost as many as 500 of these houses? It is a sad, sad lie.
Interesting argument. Let's follow it for a moment. This bus can carry almost 100 people. It costs $500,000. An airplane that can carry about 100 people costs $35 million. How can it be that one airplane costs 70 buses? Must be a scam. Or how can it be that a single stone costs a lot more than a pile of stones? Scam. Actually, for this stone, you get 11 of those neat houses in Nebraska. Or 3 of your satellites. 2 if you want a missile warning device. Just throwing in numbers into the arena and call for other people to use their common sense does not help anyone. The development of a car, for instance, from scratch costs about $1 billion. Even if the car itself will cost only $50,000 or so. Ask any economist what will contribute to the number on the price tag. Development costs. Engineers have to be paid. Costs of material. Space stuff is not just cardboard and tinfoil, even though they sometimes wrap metal foils around things for heat protection. We are talking carbon fibers, titanium, gold, rare elements. Then there are the costs for fuel. Have you ever tried to fuel up a Saturn V at your local gas station? And then there are the follow-up costs for signal receiving stations, scientists, engineers, cleaning people, printing paper and so on. Not sure about you, but usually people like to get paid for their work. Are there any other questions? Yes, Eric?
167. Satellites are allegedly floating around in the thermosphere, where temperatures are claimed to be upwards of 4,530 degrees Fahrenheit. The metals used in satellites, however, such as aluminum, gold, and titanium, have melting points of 1,221, 1,948, and 3,034 degrees respectively, all far lower than they could possibly handle.
In my video, Does Vacuum Really Suck? I explain why things don't heat up in the thermosphere. The density of hot molecules is just very small, and so you do not get much energy from those hot molecules. To illustrate this, here is a little experiment. Paper burns at 360 degrees Celsius. A candle has over 1000 degrees and is hot enough to burn it. But when the paper moves through a space where it only now and again encounters a candle, it won't even get charred at all. So when a satellite encounters a hot molecule in the thermosphere, it absorbs part of this energy and then radiates it away. Just like the paper could not be burned by a short fire, the satellites won't melt from a few hot molecules.